Hello coders, I welcome you all. In the last video of our MLOps playlist, we created a complete MLOps project for water potability prediction using machine learning. As you know, we prepared and ran several experiments. Then we identified the best experiment, meaning the best model with the best hyperparameters, right? And we logged everything including all the experiments using MLflow on desktop. After that, we created a DVC pipeline and registered the best model in the MLflow model registry, which is available on desktop. After that, we created a desktop application which performs prediction by fetching the best model which is registered in the MLflow model registry, right? And we have completed our project in 4 sections: setup, experiments, then we created DVC pipeline, and then after we registered our best model on the MLflow model registry, which is available on desktop, like this. And we have planned our experiments in this way, right? First, we have used baseline model. Then we fill missing values using the median. Then we fill the missing values using the mean. And we have used these many classifiers. After that, we found our best classifier on this particular dataset, random forest classifier. After that, we performed hyperparameter tuning. And this is our findings from the experiments. As you know, we found our best model along with the best imputation technique for filling missing values. Best model, random forest classifier. Best imputation technique for missing values is mean. And best values for the hyperparameters of our random forest classifier. N estimators 1000 and max depth is none. As you know, after performing these experiments, we have created DVC pipeline, right, with our best model. So we can execute our entire experiment with just one command because the DVC pipeline is easy to maintain and scalable as well, right? So it was amazing journey, right? Showing how MLOps ties everything together that we have completed in our last video of our MLOps playlist. In the today's video, we will take it a step further. We are going to learn how to integrate continuous integration into our MLOps project in this particular project, right? So in the first step, we will set up a GitHub Actions to automatically run our DVC pipeline on the GitHub Actions runner. Whenever a push event occurs, I'm repeating, in the first step, we will set up GitHub Actions to automatically run our DVC pipeline on the GitHub Actions runner. Whenever a push event occurs, I hope you can understand this because I have already covered basics of CI/CD pipeline. Okay, in short, we want to run our DVC pipeline on the GitHub Actions runner space. After that, we will include a step to check whether our model loads properly or not from MLflow model registry. After that, we will perform a performance test and check the accuracy. If it meets the threshold, only then we will consider it. Otherwise, not. So let's get started. If you already have the code for our MLOps project that we have completed in the last video, you can directly start building the CI configuration file. However, in this video, I will first create a DVC pipeline and then integrate the CI continuous integration workflow into our project. So let's get started. Now let's open command prompt. Let's move to E drive. First, we have to install key cutter, a standard template for machine learning project, right? Let's press enter. You can see in my case, requirements are already satisfied because I have already installed cookie cutter on my computer. So now let's first download the cookie cutter template. Let's clear this. So for that, we have to write following command: cookie cutter -c v1 https github.com/driven data /cookie cutter -data -science. Let's press enter. Yes, I want to re-download cookie cutter. So let's press yes. Now let's give project name CI MLOps, repo name CI MLOps. You can give any other name as well. Now author name Data Thinkers MLOps project. And here you can give a short description of the project. I'm just giving MLOps project. Let's press enter. No license file. Currently, we are skipping this step, S3 bucket. Also, we are skipping AWS profile. Let's press enter. We are going to use Python 3. So 1. Now done. Now let's move to this particular directory. You can see. And now let's open VS Code from here. You can see various folders and files designed to manage our machine learning project that you can see. So first, let's remove unnecessary files from the current project structure because we are going to create them from scratch, right? So let's move to src data. Let's delete this. Also, this Python file, as I said, we are going to create them from scratch. So remove this all files. Let's check models. Let's delete this. And let's remove these Python files, which is defaultly provided by cookie cutter template. But as I said, we are going to create them from scratch. That's why we are removing all these files. Now done. Also, let's rename this from models to model. I think all done. Let's click on terminal and let's press new terminal. Let's clear this and let's create a new virtual environment first using following command: python-m venv and my-env. Let's press enter. You can see we have successfully created our virtual environment. Now let's activate our created virtual environment. So for that, we have to write following command: my-env/script/activate. So if you are getting the same error, you have to use following command before you activate your virtual environment. This command. Let's press enter. Now let's activate our virtual environment. You can see. Let's clear this. Currently we are in our virtual environment, right? Now let's check pip list. You can see these two packages are already installed, right? Again, let's clear this and let's perform git init. Let's check git status. You can see these many untracked files because just we have created a cookie cutter template. So let's clear this. Git add dot. Let's add all the files into the staging area. Let's commit the changes. Add cookie cutter template. Let's press enter. Now all done. Let's clear this. Now here we have to create a remote repository on GitHub. So let's jump to GitHub. So you can see currently I'm using my GitHub account. Let's press new. And here you can give any name to your repository. I am keeping it public. Let's keep other things as it is. And let's press create new repository. Now let's copy this. Let's move to VS Code. Let's move to VS Code. Let's add our remote repository. So for that, we have to write following command: git remote add origin and this URL. Let's press enter. Done. Let's perform git push origin master. Let's press enter. Done. Check on GitHub. Let's reload this page. And you can see here our cookie cutter template available on GitHub in our repository that you can see. As you can see, just we downloaded the cookie cutter template and set up GitHub and pushed our code to GitHub. Now let's move on. We are going to set up MLflow on desktop. So now let's move to desktop. You can see I already logged in into my desktop dashboard that you can see. Now let's press create new repository. You can see we have three options: create blank repository, create from template, connect a repository. Since we have a repository, let's press connect a repository. Again, here we have two options: GitHub and other. Since we created the repository on GitHub, let's connect using GitHub. Here we have to provide password. Now, after that, you will see this particular page. And let's remove my previously connected repository and let's add this particular repository and let's press save. You can see this particular repository just we have created on GitHub. You can see that we are connecting over here on desktop. Let's press save button. After that, you will get this page. Choose a repository to continue. So let's click over here and we have to press connect repository. Let's press no, thank you. And you can see we have successfully connected our GitHub repository to desktop. So let's click on remote and experiments. You can see this code we required to connect our project with MLflow on desktop. So let's copy this and I am going to paste on Notepad. Also this code to check connection to MLflow and go to MLflow UI. Now you can see our MLflow is running on desktop. Here you can see experiments and models. So here we are going to log everything on desktop using MLflow. So we have successfully completed this particular step. We have successfully connected GitHub repository with desktop and also we are running MLflow on desktop. So now let's move to VS Code back. You can see currently we are inside our virtual environment, MyEnv, which is separate from the base environment. So here we need to install the required dependencies. So first we have to install MLflow using following command: pip install MLflow. We have to wait, it will take some time. You can see we have successfully installed MLflow in our virtual environment, MyEnv. Let's clear this. Also, we have to install desktop. Again, we have to wait, it will take some time. Now you can see we have successfully installed desktop in our virtual environment. Let's clear this and also we have to install Seaborn. Now done. Now we have successfully installed required dependencies into our virtual environment that we have created with name MyEnv. So as you can see, we have stored required information into Notepad. Now let's perform a test to see if we are able to log the experiment or not. So let's copy this and inside this notebook, let's create a new Python file with name desktop_test.py. Let's paste this script over here. So as you know, we have taken this script from desktop, right? It's an example script just for testing the connection with MLflow currently running on desktop. Now let's run this particular script, Python, and let's copy path, paste it over here. Let's press enter. Now done. Let's check on desktop. Let's reload this page. Can you see? We can able to log parameter with default value as value and default metric name as 1. That you can see, parameter name value and metric name 1. So as you can see, we are testing with this dummy parameters. So you can see we have successfully logged these dummy parameters on desktop. Now we can say our connection with desktop is working properly. So now let's move to VS Code and we are going to create a DVC pipeline. I am going to use the same code as before that we are using since long. Let's clear this and first let's initialize DVC. You can see we have successfully initialized DVC. Let's clear this and for data versioning we are going to use a local disk for storage and we are going to store our data in a temp folder. DVC remote add -d my remote and location of temp folder. Let's copy this and let's paste it over here. Let's press enter. Now you can see setting my remote as default remote. You can see we have set up a Git remote repository to maintain different versions of the code and DVC remote to manage different versions of the data. This setup allows us to retrieve particular versions when needed. So now let's build the DVC pipeline. You might already know the 4 stages we have created: data collection, data pre-processing, model building, and model evaluation. So we are going to create the same stages here. Now we have to add the Python files to this template. So let's move to SRC. Here, let's click on data and let's create new Python file with name data underscore collection dot py. Let's move to our previous project, and this is data collection file. Let's copy this and let's paste it over here using exactly same code that we are using since long. Let's save this file. The only change I have made is this. In place of using dataset from our local computer, I have uploaded the dataset on GitHub, and I am using the link to fetch the data from GitHub, nothing else. Otherwise, I am using exactly same code for data collection, right? Again, let's click on data folder. Let's create new file, data underscore prep dot py. Let's select this code. Let's copy this code and let's paste it over here. Let's save this file. Now done. Let's click on model and let's create new Python file with name model underscore building dot py. Again, let's select this code. Let's copy this code and let's paste it over here. Let's save our file. Exactly same code, right? That we are using since long for model building. Again, let's click on this particular folder model, create new file with name model underscore eval dot py for model evaluation. Again, let's select this code. Let's copy this code and let's paste it over here. Let's save our file. Now we have to create params.yaml file. New file params.yaml. Let's select this. Let's copy this. Let's move to our project. Let's paste it over here. And here you can see we are using hyperparameter with value 1000 that we found during our experiments, right? Let's save this file and let's create a very important file, dvc.yaml file. Let's select this code. Let's copy this code. Let's move to our project and let's paste it over here. Also, we are going to add one more file, right? That we have created in our last video of our complete MLOps project, model underscore register dot py, that will automatically register our based model on MLflow model registry when we run our DVC pipeline. So let's select this, let's copy this, let's paste it over here. Let's save our file. And as you can see, this particular step we have already added as a one of the stage of our DVC pipeline. You can see model registration. So when we run our DVC pipeline, it will automatically register our based model on MLflow model registry. Now let's move to this particular file. So currently we are in model underscore eval.py. We have to change this connection related information. So let's move over here and we have to take this information, right? Let's copy this. Let's paste it over here. And again, I'm using same name. So MLflow.set underscore experiment. Experiment name is final underscore model. Let's keep as it is. Let's copy this. Let's move over here and we have to use here as well. Let's save our file. Also this particular file. So just we have added this information into our model underscore eval.py and model underscore reg registration.py. Now done. Let's clear this and let's execute our DVC pipeline using this particular command, DVC repro command. So it will run, you can see each and every steps that are mentioned inside dvc.yaml. You can see currently we are at model underscore building.py. Now done. Now we are at model underscore eval.py, which is also done. We have to wait. It will take some time. You can see data underscore collection.py, this one. Then next stage, pre-processing. You can see this one. And next, model building. You can see. Then model evaluation. You can see. So currently we are at this particular stage, model evaluation. You can see this. After that, it will run model registration and it will register our model onto MLflow model registry here, right? So we have to wait. It will take some time. And you can see here our final underscore model. As you can see, model evaluation step is completed. Model registration is also completed. And you can see created version 1 of model based model. Let's check on DexUp. Let's reload this page. You can see this is our model. with test size 0.2 and n estimators 1000 and F1 score recall accuracy and precision that you can see for this particular model with this hyper parameters and with their based values. Now let's go back and let's click on models. You can see based model version 1 and version 1 in production. So we have successfully registered our based model into MLflow model registry, right? So now let's move on. So as we discussed, we are going to run our DVC pipeline on GitHub Actions runner space. So we need to install every dependencies over there, right here on GitHub Actions runner. So we have to store every dependencies somewhere. And as you know, for that, we are using requirements.txt, right? So for that, let's move to VS Code. Let's clear this and let's store every dependencies into requirements.txt. Let's click over here and you can see every packages that we have used here locally, right? That we have successfully stored inside requirements.txt. Same we will install on GitHub Actions runner space. So as we discussed, we are going to create a CI workflow to execute the DVC pipeline on the GitHub Actions runner space instead of running the DVC pipeline locally, right? That just we have done. We will run it on the runner space. So for that, we need to create a .github folder. So let's click over here and let's create new folder with name .github, and inside it, we have to create another folder with name workflows. Let's press enter. Done. Now into that, we have to create our CI workflow file. So let's click over here and let's create ci.yaml file. You can give any other name as well. And you can see I have already created it, right? And this is name of our CI workflow, CI pipeline. And this workflow will be triggered on push event. And here we have one job that you can see with name project-testing. You can give any other name as well, which is run on Ubuntu latest. Currently, we are using only one operating system, Ubuntu. And this is our first step. Check out code from GitHub repository. Next, set up Python. And here in the next step, we are installing different dependencies. You can see from requirements.txt that just we have created, right? And finally, we are running our DVC pipeline. So our pipeline will run on GitHub Actions runner space. Let's save this file. Let's check Git status. You can see this many untracked files. Git add git commit -m initial commit. You can give any message. Let's press enter. Done. Let's clear this. Let's perform git push origin master. Let's press enter. I think all done. Let's move to GitHub. Let's click on actions and you can see our workflow is triggered on push event. Let's click over here. You can see starting job. Now it is installing different dependencies mentioned inside requirements.txt. And here we have this particular error. No matching distribution found for PyWin32 equal 308. Let's move to VS Code requirements.txt and we have to search for this one, PyWin32. Let's remove this. Let's save our requirements.txt. Again, let's clear this. Again, git add git commit -m. Remove PyWin from requirements.txt. Let's press enter. Again, git push origin master. Let's press enter. Now this push event will trigger our workflow. Again, let's click on actions. You can see our commit and our workflow has been started on push event. You can see again installing dependencies. Now hope it works. Now done. We have to wait. It will take some time. Now you can see now it is running DVC pipeline and we are at model building stage. Now you can see we are getting this particular message, authorization required, right? And you observe we are running our DVC pipeline on GitHub Actions runner space that you can see. And we are getting this particular message, authorization required. Now let's resolve this issue. This authorization is required by DexUp. For those who worked with me on the last project, you might remember receiving this authorization request via the GUI, which looks something like this. right? And you accepted once by pressing this particular button, and it was not required again. Since we are running our code for the first time on this runner space, it prompts us to perform the authentication through the browser. However, performing this on this console is not possible over here, right, on the runner space. So we need to use another type of authorization once we have performed based on GUI. But here, which is not possible on console, so we need to use another type of authorization, which is key-based authorization, also called as token-based authorization. We need to obtain the key from DexUp and include it in the CI configuration file here before we running our pipeline. Using this particular token, authentication will be performed. So for that, let's move to DexUp and let's generate token for token-based authorization, right? In place of GUI-based authorization. So let's move to DexUp and let's create token for authorization. As you can see, currently I am on DexUp and I'm using dashboard of DexUp. Here on the right side, you have to click on your settings and you can see here tokens. Now these many tokens I have already created. Now let's generate new token. And here MLOps project underscore CI. You can give any other name as well. Let's click on generate token. You can see we have successfully generated our token. So here we have to copy this token. Let's paste it over here on Notepad. So actually we need to add this token to the CI configuration file. So actually we need to add this token over here, but it's not proper way to include it directly in the file, right? So instead of adding it directly over here, let's add the token to GitHub secrets first. From GitHub secrets, we will include it over here in the CI configuration file. So for that, let's go to GitHub. You can see currently I'm on my GitHub dashboard. Let's click on settings and here secrets and variables. And we have to click on actions and here new repository secret. Let's click over here. You can give any name. Let's give DexUp underscore token. And here, let's copy this and let's paste it over here. Now, when I press add secret, you can't see it anymore. Means never again, right? We can access this secret through this name only. We can't see this secret again. After pressing this button, add secret. Let's click over here, add secret. Now done. You can see, so as I said in the CI configuration file, we have to add this. So let's move over here and before run, here we have to create one variable env and here DexUp underscore token and here secrets dot DexUp underscore token. So we have to access like this. Save our configuration file. Done. Now let's click on model underscore eval.py. You can see we are using this code to connect to DexUp. So this code will not work because it's for browser-based authentication. We need token or key-based authentication. So we have to modify this code accordingly, right? Because in place of browser-based authentication, now we are performing token or key-based authentication because currently we are running our DVC pipeline on GitHub runners space. So this code will not work. So let's comment this code. In place of this, we have to use this particular code. It's a very simple code. Here we are performing token-based authentication, nothing else, right? Because we have created secrets on GitHub secrets with this particular name that we are providing over here, nothing else, right? So this code performs token-based authentication. And here we are providing DexUp repository details. Just we have to change this repo name as per the current repo, this repo owner and repo name. Let's copy this and let's paste it over here. And here we have set tracking URI by providing this information to connect with DexUp. And here our experiment name, final model. Let's save our file. So again, this information we required in another file as well, from where also we are connecting with DexUp here. Again, let's comment this code and here in place of this, we have to perform token-based authentication. That's why here we are using this code. Same, let's save this file, clear this, and it's better to perform DVC push first. That will move all the data sets from cache file to our remote storage that we are using in temp. Done. Perform git status. You can see these many files are modified because we have added token based authentication. Let's clear this. Let's perform git add, git commit token based authentication. Let's press enter. Now perform git push origin master. So when I press enter, it will trigger our CI workflow. Now done. Let's move to GitHub actions. You can see token based authentication and our workflow has been started on push event. Let's click over here. You can see it is installing dependencies. We have to wait. It will take some time. You can see template is not valid and unexpected value for dexup underscore token in our CI workflow file. Let's check. Oh, here we require space. Now you can see color has been changed. Sorry for this. Again, we have to save this CI configuration file. Let's clear this. Git add dot git commit -m error in CI workflow. Let's press enter. Git push origin master. Let's press enter. Now it will trigger our CI workflow, this particular file. Let's move again. Let's click on actions. Hope now it works. Let's click over here. You can see CI workflow has been started. Install dependencies. Please wait. It will take some time. Now you can see run DVC pipeline. We are at model building stage of our DVC pipeline. And you can see currently we are running our DVC pipeline on GitHub actions runner space. You can see we are at model evaluation stage. I hope it works. Again, we have to wait. It will take some time. Now done. Great. We have successfully run the DVC pipeline on the GitHub runner space that you can see. And here green tick because we have successfully executed our CI workflow file. Now you can see we can able to run our DVC pipeline on the GitHub runner space. You can see. Let's check on MLflow. Load this page and you can see version 2 has been created. And this is our previous version, which is in archive stage. And this is our version 2. This version 2 has been created because we run our DVC pipeline one more time. You can see through GitHub actions runner space that you can see. Now we can say we have successfully run the DVC pipeline on the GitHub actions runner space. And you can see green tick, right? And also we have registered our version 2 successfully on MLflow, which is running on dexup. Hope all of you are clear with this. Now let's move on. You can see that our DVC pipeline is now running on the GitHub actions runner space, right? Next, we are going to perform some tests that will be automatically executed when developers push their code changes to GitHub. When developers push their changes, we want to execute our CI workflow. This workflow will first run our DVC pipeline like this that you can see on the runner space. And then we will perform the test. We can run many types of tests, but just to explain you the concept of CI workflow and how to integrate our CI workflow with MLOps project, we are going to perform two tests. In the first test, we will check whether our model loads properly or not from the MLflow model registry. After that, we will perform a performance test to check the accuracy. If it meets the threshold, only then we will consider it successful. If the test pass or fails, developers view the results on the GitHub over here, right? So let's start with our first test where we are going to check whether our model loads properly or not from the MLflow model registry. So let's move to VS Code. Before we move, we have to perform one changes. As you can see here on the MLflow, currently we are directly sending our model to production. But first, we want to send our model to the staging area where we will perform different tests. If all the tests are successfully passed by our model, then only we will move our model to the production, right? So let's save this. Let's check Git status. You can see we have modified this particular file. Let's clear this. Git add dot git commit, putting model into the staging area. Git push origin master, right? So this statement will trigger our workflow, our CI workflow, right? This one. Let's press enter. Done. Let's move to GitHub. Let's click on action. As you can see, staging, have to wait. It will take some time, right? As you can see, our current stage, version 2 in the production. You can see. So now this flow will create a new version, version 3, and it will put this version 3 into the staging stage in place of production, right? Now you can see. Now it is running our DVC pipeline. You can see created version 3 of model based model. Let's check, reload this. You can see version 3 has been created and currently it is in the staging stage where we are going to perform various tests on this particular model. If this model passes the test, then only we will move this current model which is currently in the staging stage to the production stage. So we will perform various tests on this particular model which is currently in the staging stage. If it is passes all the tests, then we will move this particular model to the production stage. Now all done, right? So now let's start with our first test. As I said, where we are going to check whether our model loads properly or not from the MLflow model registry. From here, this particular model, version 3, which is currently in the staging stage. So in this test, we are going to check whether our model loads properly or not from the MLflow model registry, right? So now again, let's back to VS Code. So first, let's create new folder with name test where we will write our test script. And here, let's create our Python script with name model underscore test dot py. I have already created this particular script. Let me show this. So this is our file. Here we are importing various libraries. And as you know this code, right? Here we are performing authentication for DexUp. And here we are specifying the name of the model that we want to load and test, right? Based model. So this is the model name registered in the MLflow, right? Let me show this. You can see based model. And here we have created one class with name test model loading, which contains this particular method test underscore model underscore in underscore staging. Test if the model exists in the staging stage. And here we have initialized MLflow client to interact with the MLflow server. Here we are retrieving the latest versions of the model in the staging stage that you can see. In our case, version 3 that you can see. Currently version 3 in the staging stage. And here we are using assert greater. Assert that at least one version of the model exists in the staging stage. If no versions are found, it raises an error. This particular error, no model found in the staging stage. After that, we are performing test model loading. Here we are testing if the model can be loaded properly or not from the staging stage. Here we initialize the MLflow client again to interact with the server. Again here we retrieve the latest versions of the model which are currently in the staging stage. In our case, version 3. Again, if no versions are found, fail the test and skip the model loading part. If it is there, here we are getting the version details of the latest model which is currently in the staging stage. Again, here we retrieve the run ID of the model version. Here we are constructing the string needed to load the model using its run ID, right? And here in the try and accept, in this exception handling part, in try, we are trying to load the model from the specified path, this path. If loading the model fails the test and output the error message, this particular. And at the end, assert that the model is not none, meaning that it was loaded successfully, right? And as you can see here, we are using assert is not none. Assert that the model is not none, meaning it was loaded successfully. At the end, we are printing this particular message on the console. Model successfully loaded from this path. And here we are executing unit test. Now this is our script. Next, we have to update our CI configuration file, this file, because we want to perform this test on the push event that you can see. So let's add the next stage to our CI workflow. Here you can see I have added this particular stage, exactly same that you can see. Here we are performing authentication with DexHub using this DexHub underscore token, right? And here we are running our script unit test, and our test script is available inside this test/model underscore test.py that we have created over here. This one, model underscore test.py. Now let's save this. Let's clear this. Let's check git status. You can see we have modified this file. Git add dot git commit -m unit test git push origin master. Let's press enter. Let's move to GitHub and let's click on actions. Let's click over here. You can see currently it is installing dependencies. Now you can see it is running model test, and you can see it is downloading artifacts. You can see ran to test model successfully loaded from this path that you can see. You can see that we have successfully executed our CI workflow, and here you can see which is indicated by the green tick. Now let's also check what happens when we can't load the model. So I am entering some garbage values. Let's save our file. So here you can see I am explicitly providing the wrong information just to check what happens when we can't load our model. So again, let's clear this. Git status. You can see we have modified this particular file. So again, git add, git commit. I'm keeping this message. Again, git push origin master. Let's press enter. Now let's move to GitHub and let's press actions. You can see. Let's click over here. Again, we have to wait. It will take some time. Now you can see run DVC pipeline. Again, we have to wait. It will take some time. Now you can see run model test, and you can see here run to test and failed error 2. As you know, we have explicitly generated this error just to check what happens when we can't load the model. You can see the errors because we cannot load our model from the MLflow model registry, as a model with this particular name is not available, right? So now let's change it with the proper name. Let's save this file. Let's clear this. Git status. Let's clear this. Git add, git commit, git push origin master. Let's back to GitHub. Let's click over here, actions, and you can see now our CI job will be executed successfully, that you can see. Again, we have to wait. It will take some time. Now you can see our job will be executed successfully. We have to wait. It will take some time. Now run DVC pipeline. Now all done. You can see model successfully loaded from this particular path. So you can see that we have completed our first test, which checks whether the model is properly loading from the MLflow model registry or not, that you can see. Now let's move to our next test, where we are going to evaluate the model's performance in the terms of accuracy, precision, recall, and F1 score to determine if it meets the threshold or not. Now let's move to our next test, where we are going to evaluate the model's performance in terms of accuracy, precision, recall, and F1 score to determine if it meets the threshold or not. Let's move to VS Code, and we are in model underscore test.py, our test script. In this particular script only, we are going to add one more function. You can see just I have added this particular function to check for model performance in terms of accuracy, precision, recall, and F1 score. You can see test the performance of the model on the test data. We are fetching the latest version of the model, which is currently in the staging stage. Here we are getting run ID, constructing the model path, and here we are loading our model. Here we are loading our test data, and here we are separating our independent and dependent variable. Here we are making predictions on our test data, this one. And here we are calculating accuracy, precision, recall, and F1 score using actual values and predicted values by our model from here. And here we are printing accuracy, precision, recall, and F1 score on the console. Here we are using assert statement. Assert greater than equal. Assert performance metrics meet thresholds. Currently, we have set this threshold to 0.3 for accuracy, precision, recall, and F1 score, just for testing purpose, right? If it is not meet these particular thresholds, then it will print this particular message. Accuracy is below threshold, precision is below threshold, recall is below threshold, F1 score is below threshold. If it meets, then it will print the accuracy, precision, recall, and F1 score as it is. Let's check. Let's clear this. Hit status. As you know, we're not required to change this CI configuration file because we have added our new function into this file only, right? Let's check git status. You can see we have modified this particular file. Hit add model performance test. Let's press enter. Hit push origin master. Let's press enter. Now let's move to GitHub. Let's press actions. And you can see again we have to wait. It will take some time. Now you can see it is running our DVC pipeline. You can see now it is running model test, and you can see over here because it meets the particular threshold. That's why you can see ran 3 tests and okay. And now because of these statements, it prints accuracy, precision, recall, and F1 score. Now let's change it to 7. Save this. Just I want to show you what happens if it does not match the particular threshold. Let's clear this. Git add dot. I'm keeping this particular message for commit, and again git push origin master. Let's move to GitHub. Let's click on actions. Let's click over here. Again we have to wait. It will take some time. Now it's running our DVC pipeline. Now all done. You can see because of this many tests that we have performed, and we have executed our DVC pipeline again and again. So currently our version 8 of the model, which is currently in the staging stage, that you can see. Now run model test. Now you can see that I want to show you this failed, and you can see assertion error. Accuracy is 0.68, not greater than or equal to 0.7. Accuracy is below threshold, that you can see. So failed message is something looks like this that I want to show you, right? Now let's back VS Code, make it to 6. Let's save this. Let's clear this. Again, one thing I want to show you is, and here you can see red cross because our test fails, right? Okay, now let's back to VS Code. Again, git add dot. I'm keeping the same message, git push origin master. Let's back to GitHub actions, and let's click over here. Again, we have to wait. It will take some time. Now you can see we are at DVC pipeline. Again, we have to wait. It will take some time. Now our model will pass both the tests. Now you can see run model test, 2 tests, right? Now you can see model successfully loaded from this path, and our second test, accuracy, precision, recall, and F1 score, right? And also here you can see green tick mark. So now that we have completed the model testing part, and we have performed testing while model in the staging stage, right? And we have verified using CI workflow whether the model is loading properly from the MLflow registry or not. And also we have checked the model's performance as per our decided threshold. And now we are confident that our model is running and working properly, right? That you can see. Hope all of you are clear with this, right? In short, we have completed testing the model in the staging stage. Now we can move this model to production, which we are going to do next. In short, we are going to put our model from staging stage to production stage because it passes 2 tests, right? So let's move to VS Code, and here I am going to create one new folder with name scripts. You can use any other name as well. In that, let's create one new file, production.py. You can give any other name as well. Now this script is also very simple. Let me show this. I have already created this script for production. So this is our script. So what we are doing in this particular script? Here we are checking if any model is currently in production. If so, we move that model to the archive and promote the current model in the staging stage to production stage. If no model currently in the production stage, means our production stage is empty, then promote the current model in the staging stage to production stage, right? That we are doing here. Again, here we are importing libraries that we require. Here again we are performing authentication for DAXUP. This is our model name, and here our method promote underscore model to production. Again here you can see we initialize MLflow client. Here we are getting the latest model which are currently in the staging stage, that you can see. Fetching the version latest underscore staging underscore version, the latest model currently in the staging stage, that we are fetching over here, right? If any model currently in the production, that we are fetching over here. If production underscore versions, if one model is available in the production stage, we are putting that particular model into archive and promote the current model which is currently in the staging stage to production stage, that you can see, right? So it will display archive model version in production and no model currently in production. And here transition the latest staging model to production. As I said, no model currently in the production, then promote the current model which is in the staging stage to production, that we are doing over here, right? And here we are displaying this message. So that's why here we are using if and else, as we discussed earlier, right? First, we are checking if any model is currently available in the production stage. If yes, we are moving that particular model to archive and promote the current model which is in the staging stage to production. If not, means no model currently available in production stage, then we are promoting the current model which is currently in the staging stage to production. As simple as that, right? This is about our script. Promote our model to the production which is currently in the staging stage. Now here also we have to do one thing. We have to add one stage into our CI configuration file here. So I have added this name of this stage, and here we are performing authentication with DAXUP, token based authentication, right? And here we are running our script production.py, and here you can see if success, which means this particular step will be executed only if all the previous steps have executed successfully. This all, right? Otherwise not. I'm repeating, here we are using if success, which means that this particular step will be executed only if all the previous steps have executed successfully, right? And this is logical, right? First we are performing test, then only we want to promote our model to production, that we are doing here. Let's save this file. Let's clear this. Git status. You can see we have modified these files. Let's clear this. Git add dot git commit m model to production. Let's press enter. Git push origin master. Let's press enter. Now done. Let's move to GitHub. Let's click over here. Actions. You can see here model to production. Click over here. And please look at here. Currently our version 9 in the staging stage, that you can see. And current version in the production is version 2. Now you can see after this all, you will see version 9 over here in the production. Again, we have to wait. It will take some time. You can see now it is running DVC pipeline. You can see test has been started. Now you can see our first test has been completed successfully. Now also our second test. Now you can see promote model to production. Sorry, you can see promote version 10 to production because we have executed our DVC pipeline one more time, right? For this particular commit. So in place of version 9, version 10 has been created and which is currently in the production. All done. Let's check on MLflow. Reload this and you can see version 10 in the production because it passes all the tests, right? Our 2 tests. Hope all of you are clear with this, right? So you can see that we have added continuous integration to our MLOps project. First, we performed testing, and if everything was correct, we moved our model to production, that you can see here. I hope all of you are clear with how to add CI continuous integration to our MLOps project. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.